Okay, here in section 5.2, the last section in week 5 of Precalculus, we want to talk about the sum and the difference formulas. And these are important formulas that you will use as you move on with more and more mathematics. So these are important for us to go over. And these are the examples we're going to talk about doing them. But first of all, let's understand what the sum and the difference formulas are. So these are the sum and difference formulas. So basically, if I want to add or subtract two angles, right? Alpha and beta here are angles. So the sine of alpha plus or minus beta is sine alpha cosine beta plus or minus cosine alpha sine beta. So in other words, this plus goes with the plus and this minus goes with the minus. The cosine of alpha plus or minus beta is cosine alpha cosine beta minus plus. So I shifted their order, which means the plus here goes with the minus here goes with the plus. Okay, sine alpha sine beta. Now, I remember these with a sort of a mnemonic device for me. I think of sine as a friendly function that likes to include the cosine function and then doesn't change the sign here, S-I-G-N, of these guys. Cosine is an unfriendly function, doesn't want cosines to be involved with it at all. So it's going to stick with just cosines here and then throw away the signs over here. So if it's a plus, it's minus, and if it's a minus, it's plus. Okay, so that's kind of my way of remembering these. You could just put them right down your cheat sheet if you don't want to think you want to remember them and you might need them. Just put them on your cheat sheet and just remember them that way because you don't need to memorize them if you don't want to. The tangent of alpha plus or minus beta, I don't really have a good mnemonic device for that, but it's just tangent of alpha plus or minus tangent of beta, then divided by 1 minus plus. So in other words, the plus minus stays the same up here, but if it's a plus here, it changes to minus down here. If it's a minus here, it changes to plus down here. Tangent alpha, tangent beta. So you just need to be able to use these formulas, okay? All right, so for example, let's write as the sine, cosine, or tangent of an angle, then find the exact value. So notice what we have is we have cosine times sine, and then plus a sine times cosine. So this is a sine function because it's friendly. It's involving the cosine with itself. So I'm thinking to myself, okay, that's the sine, and it's the plus sign. So sines, the S-I-G-N stayed the same. So this is going to be the sine function of 7 pi over 12 plus pi over 12, right? Sine of 7 pi over 12 plus pi over 12. In other words, this is the sine of 8 pi over 12, which is the sine of 2 pi over 3, which comes out to be square root of 3 over 2. Here's 2 pi over 3. In other words, my reference angle is 60 degrees because that's 120 degrees, right? 2/3 of pi is 120 degrees. So my reference angle is 60. That means 30 is up here. So I know that the hypotenuse is 2, side opposite 60 is root 3, side opposite 30 is 1, but I put a minus 1 because it's on the negative x-axis. But I just want the sign of it, so it's opposite over hypotenuse, which is square root of 3 over 2. All right, let's find the exact value of this guy. Tangent of, okay, I have an alpha minus beta. So remember, that's tangent of alpha minus tangent of beta over 1. This sign, S-I-G-N, changes 1 plus tangent alpha, tangent beta. So you have to plug all that stuff in and simplify it, but the bottom line is you just need to know what the tangent of 3 pi over 4 is and the tangent of pi over 6 is. So 3 pi over 4 is this guy, which means its reference angle is pi over 4 or 45 degrees. So 45 degrees 90 makes 1 root 2. Put a negative 1 here because it's on the negative x-axis. Pi over 6 is 30 degrees, 1/6 of pi, right? 30 degrees. So side opposite 30 is 1, side opposite 60 is root 3. Hypotenuse is 2, so it just becomes a matter of simplifying these numbers here, and you can look through that and make sure you know how to do that. All right, now example 3. Given that the tangent of alpha is 3/4, and we're told that alpha is in quadrant 3, so alpha is all the way down here. I know the tangent is 3/4, so my reference angle is just this guy. I don't really care what the reference angle is, but I'm going to draw my reference triangle, and I know the side opposite over adjacent has to be 3/4, but that's a negative y, so that's minus 3, and that's a negative x, so it's minus 4, and then it simplifies to 3/4. That means the hypotenuse is 5. Either use the Pythagorean theorem or recognize we have a 3, 4, 5 right triangle. And then I know the sine of beta is 8/17, where beta is in quadrant 2. So here's beta in quadrant 2. The sine is opposite over hypotenuse is 17. You can use the Pythagorean theorem to see this is minus 15, the minus sign because it's on negative x-axis. Or you recognize an 8, 15, 17 right triangle, either way. Okay, So then we want to find the cosine of alpha plus beta. So that's the cosine. Remember, cosine's unfriendly. So it's cosine of alpha times cosine of beta, and then I change the sine SIG in, minus sine alpha sine beta. So plug all those numbers in and simplify. You get 84/85. Sine of alpha plus beta is, sine's the friendly function. So it's sine alpha times cosine beta plus, the SIGN stays the same, cosine alpha sine beta, right? Includes cosine with it. Plug all those numbers in, you get 13/85. Tangent of alpha plus beta, well, that's tangent of alpha plus tangent of beta over 1 minus tangent of alpha tangent of beta. Plug all those in, you get 13/84. Okay, our last example, given that the cosine of alpha is 2/3 and alpha is between 3 pi over 2 and 2 pi, in other words, it's in the fourth quadrant over here. Cosine of alpha, then its reference triangle is, its reference triangle, sorry, my dog started to bark, but he's stopping now. So the reference triangle is reference angle is right here. So the reference triangle is this guy. You know the cosine of alpha is 2/3, which is adjacent over hypotenuse. That means I can figure out the opposite side from the reference angle by using the Pythagorean theorem and recognizing that it's negative. So negative square root of 5. Then I need the sine of beta is 1/5. Okay, so where beta is between 0 and pi over 2, which means the first quadrant. So 1/5, opposite over hypotenuse. I can figure out the adjacent side from the Pythagorean theorem. It comes out to be square root of 24 or 2√6. So then I can do cosine of alpha plus beta. Cosine's the unfriendly function, so it only includes cosines, throws away the sines. And then I can do sine of alpha plus beta. That's the friendly function. It includes cosine, keeps the SIGN the same. Work that out. And tangent of alpha plus beta again, and work that out. So it becomes a little tedious or arithmetically to get the exact answer, but you can work through it and see what you get. And that's kind of a tedious answer. So, but the bottom line is it's just arithmetic at that point once you understand the trigonometry.